While the European Space Agency has many huge achievements under its name, its operations and politics may be a bit confusing. This is mostly due to one fundamental difference between it and other agencies. We are used to connecting space programs in our heads to countries. The USA has NASA, Russia has Roscosmos, India has ISRO, and China has CNSA. And who exactly has ESA? Is it the European Union? No. The member countries? Kind of. Its unpretentious line of work and national ambiguity make it quite a misunderstood agency that most Europeans don't really care about, and certainly nobody casually wears their logo on a t-shirt. I believe this huge unsung hero deserves a lot more acknowledgement and public interest. After all, European Space Agency is a very active member of the industry, and our common future is heavily dependent on it. That being said, there are also some controversies regarding its operations. So what exactly is ESA? What does it actually do? Where does it get all the money to fund those projects, and why isn't it a part of the European Union? It's Rebus Space here, and all of it and more in this video. Just as stated in the introduction, most people don't really know what ESA is and what are its tasks. It is often structurally compared to NASA, which can lead to many misunderstandings as the two organizations are vastly different. The European Space Agency is an intergovernmental organization consisting of 22 member countries across Europe, namely Austria, Belgium, Czech Republic, Denmark, Estonia, Finland, France, Germany, Greece, Hungary, Ireland, Italy, Luxembourg, the Netherlands, Norway, Poland, Portugal, Romania, Spain, Sweden, Switzerland, and the United Kingdom. It is a separate institution from the European Union, in fact preceding it by 18 years. ESA was first founded in 1975, while the EU was formed into its current state in 1993. This is also why the list of member states is missing a few countries of the EU, and also has ones that are not in the EU, like the United Kingdom, Norway and Switzerland. But in fact, ESA is cooperating with all the countries of the EU by having Slovenia, Latvia and Lithuania as associate members, and by having special cooperation agreements with Bulgaria, Croatia, Cyprus, Malta, Slovakia and for some reason Canada. So is it a common space agency of those countries? Well, again, yes and no. While all of those countries are a part of ESA, they also have their own local space agencies, some of them even working on their own projects, most notably the CNES of France, DLR in Germany, ASE in Italy and UKSA in the United Kingdom. Moreover, most of those countries also share a second institution called the European Union Agency for the Space Programme, formerly known as the European Global Navigation Satellite Systems Agency, which is actually a part of the European Union. Now let's combine all of this knowledge together to get a clear picture of where ESA stands in the European space shenanigans. First up, we have all of the countries of the European Union, plus a few more. They all have their own governmental bodies responsible for their space activities. Then, all of those countries which are part of the European Union have the EUSPA, the European Union Agency for the Space Programme, which is to manage their common space goals. And finally, all of the mentioned countries have a separate institution, the European Space Agency. Although all of those agencies are independent, the truth is that they are constantly cooperating in most fields, with the interest of the EUSPA and ESA being in line with one another, since most of ESA countries are in the EU. I will elaborate more on this relationship later on in the video. As the European Space Agency is an international project, its main facilities are scattered across the continent, with the headquarters in France, the Astronauts Center and the Space Operations Center in Germany, the Space Astronomy Center in Spain, the Center for Earth Observation in Italy, Space Research and Technology Center in the Netherlands, the Center for Space Applications and Telecommunications in the UK, and the Space Security and Education Center in Belgium. The agency also has offices for communication with the governments in Belgium, USA, and Russia. Lastly, and perhaps most importantly, its launch base is Europe's spaceport in South America, where its launches are conducted. This is also where the James Webb Space Telescope was launched on board the Ariane 5 rocket. In all of those places, the European Space Agency works on its many projects. But what exactly are they? Since the usual image of a space agency is somewhat similar to what NASA is, it may come as a surprise to many how down-to-earth the European Space Agency operations are. While most of NASA's activities are either scientific research or human spaceflight, you could say looking outside of our Earth, ESA's activities are mostly focused on what happens on Earth. This difference in approaches to running a space agency is clearly visible in their budget breakdowns. NASA spends around 45% of its money on human spaceflight and another 31% on scientific research. The same categories combined amount to only 21% of ESA's budget in 2022. Its main priorities by funding are Earth observation at 22.5%, navigation at 21.4%, and space transportation at 14.1%. While Earth application projects undertaken by ESA are numerous, two of them stand out in their importance. Their names are Copernicus and Galileo. Let's start with Copernicus, which actually is a perfect example of how all of the EU space programs are interconnected. This Earth observation program is actually an initiative of the European Commission, managed by the European Union Agency for the Space Program, but since they don't have that many capabilities, it is realized through the partnership with the European Space Agency. Quoting the agency, it aims to achieve a global, continuous, autonomous, high-quality, wide range of Earth observation capabilities, providing accurate, timely, and easily accessible information to, among other things, improve the management of the environment, understand the effects of climate change, and ensure civil security. Those goals are realized through the Sentinel family of satellites, all of which are huge, expensive, and highly specialized tools created for very specific reasons. They include emergency response, monitoring of land, monitoring of ocean and waters, and monitoring the atmosphere. It cannot be overstated how extremely useful the capabilities provided by those satellites are in situations like extreme weather conditions, flooding, drought, but also in city management, the forestry industry, agriculture, fisheries, and global shipping. The capabilities are always being expanded and new satellites are periodically added to the family. All of this is already amazing and exceptionally important, but those are not the only headline-worthy facts about it. All this incredible data is actually freely accessible online, free of any charge, through the Copernicus Open Access Hub platform. It is used all around the globe, which is clearly reflected in the numbers. On the day I'm writing this script alone, there were nearly 30,000 separate data products published, and they were downloaded over 330,000 times. And that is just in the period of 24 hours. It creates whole analytics industries, helping in nearly every area of the economy. On the other hand, Copernicus faced criticism for the same reason. Many are not happy that a European investment is also a huge source of free data for huge conglomerates such as Google, which benefit a lot from its use yet contribute nothing to its funding. The defenders of this model say that this gives Europe soft power in international relations and should stay in that form. This cannot be understated. International partners value this information, which is why many states agreed to exchange other data to have the possibility to participate more actively in the program. This includes huge economies like the US and Australia, but also India and the whole African Union. Personally, I'm somewhere in the middle. Providing this data, which is often life-saving to countries and their national services, is a noble mission, but huge non-European corporations that benefit from the program for purely commercial reasons should pay some fees for the data. This would help develop Copernicus further. You can write in the comments what you think about that. Now let's move to the Galileo program. It is another project created by the European Union but realized by the European Space Agency, further blurring the line. We often use the term GPS when talking about the location services on our phones, but that is quite inappropriate. GPS, or the Global Positioning System, is an American satellite constellation that enables location services, but it is not the only one in the world. The Russians also have theirs with the GLONASS constellation, and China also does with the Beidou constellation. Since location services became an inseparable part of our lives, serving everyone from common users like you and me, through the emergency response services, to the military and many more, the European countries did not like the idea of being dependent on other powers. That is why the European Union decided to develop its own satellite navigation capabilities with the Galileo system. If only we were so cautious in regard to gas and oil. It became fully operational and available globally in 2016, so it is likely that you have unknowingly used a Galileo satellite, for example when checking Google Maps. The chips in modern devices usually use many GNSS constellations for their data, complementing the information. There are in fact apps which allow you to check what satellites you are connected to. Here is what I got when testing it out. When the idea of such a system was first being introduced, it also created a small controversy. Since the Galileo satellites are newer than the GPS ones, they provide superior accuracy and functionality, which was not in the interest of the United States, which suggested that their enemies could utilize this superior data to have an edge over the US military. The argument was not a great one against this innovation, so the US decided to overhaul its GPS with the GPS Block 3 satellites, the last of which is expected to be launched next year. Soon, the second generation Galileo satellites are also expected to be introduced and launched on the European Ariane 6 rocket. The network is designed with innovation in mind, with a focus on autonomous transportation support and new anti-jamming technologies. This competition and technology development is highly beneficial for numerous industries. Nearly all use location services, which is why it is such an important part of the European Space Agency. Of course, those are not the only down-to-earth projects ESA works on. There are in fact many more, though usually smaller ones. Some honorary mentions include satellites measuring and mapping Earth's gravity, magnetic field and wind fields, tracking the global shipping routes, testing and implementing new telecom solutions, and creating infrastructure for data relay, so fewer ground stations are needed for low Earth orbit satellites. Analyzing our planet is really ESA's specialization, but that does not mean that the agency is any weaker on the purely scientific front. It has got many highly ambitious scientific projects in its portfolio. Some of them will be even revolutionary for our understanding of the solar system. JUICE, or the Jupiter Icy Moons Explorer, set to launch next year, will provide detailed observations of Jupiter and its three largest moons, Ganymede, Callisto, and appropriately made Europa. The Bepi-Colombo mission orbiters will study Mercury, which is the least explored planet in the inner solar system due to its proximity to the Sun. As a side note, you can see a full-sized engineering model of Bepi-Colombo at the Science Museum in London. It is really cool. The first European rover, ExoMars, was supposed to launch this year, but it was postponed due to the Russian aggression, probably until the next launch window in 2024. Right now they are figuring out alternative launch provider options, as flying on a Soyuz is no longer possible. ESA is also a frequent visitor to the ISS and a part of NASA's Artemis program, aiming to return humans to the Moon. They are contributing the European Service Module for the Orion vehicle and 2 space station modules for the Lunar Gateway, the planned space station orbiting the Moon called IHAB and ESPRIT. There are of course many smaller sized missions that I don't have enough time to dive into. You can find all of them in the links down in the description. I really look forward to making future videos about some of them. The last category of projects would be the transport vehicles that ESA is working on. Europe's rockets are built and managed through cooperation with a commercial company called Arianespace, established in 1980. The current rocket portfolio consists of a heavy lift Ariane 5 and a smaller lift Vega rocket family. Ariane 6 rocket, which is to replace Ariane 5, is right now still in development but is expected to have its first launch in the third quarter of 2022. It will halve the launch cost of Arianespace with a price tag of 75 million euros per launch, which still is much more than the offerings from SpaceX due to lack of reusability. The following project, called Ariane Next, is supposed to address this issue by once again halving the cost, but so far not much is known about that rocket. Arianespace also used to launch Russian Soyuz rockets in exchange for allowing Roscosmos to operate out of Europe's spaceport, but this cooperation was suspended and is highly unlikely to resume in any predictable future. This means that Europe does not have control of any human-rated rocket and needs to rely on its allies for human spaceflight. There is, however, one European uncrewed space transportation system expected to fly for the first time in 2023. It is called the Space Rider, and in my opinion is one of the most exciting projects the European Space Agency is working on right now. The vehicle can be best described as a reusable robotic laboratory that will be launched on the Vega C rocket to spend several months in space at a time. The experiments performed inside the cargo bay of the Space Rider will contribute to many fields, including pharmaceutics, biomedicine, biology and physical science. It will also be a great place for easier space technology demonstrations. Many of those things could be done on a regular space station, however, using the Space Rider comes with some unique benefits, the first of which is the smoother re-entry. The vehicle will be exposing the experiments to lower g-forces than the traditional solutions and parafoil down to Earth. It will also be ready soon, which cannot be said about the planned commercial space stations. If you're interested in those, you can watch my videos about the Axiom space station and the NanoRacks Outpost project, or Google Starlab and Orbital Reef. Overall, the European Space Agency works on a huge variety of significant projects, making Europe an important player in the international space market. It is a shame that many of them are not getting the attention they deserve. But besides how useful those projects are, it is also interesting how they are funded. Where do they get the money for all of those activities? Before answering this question, I'd like to remind you to leave a like and subscribe if you enjoy my content. It gives me extra motivation to learn more and work harder. But coming back to the question, how does the European Space Agency get its money? As it turns out, the answer to this question is quite more complicated in comparison to, for example, NASA, which gets its money from the government of the United States. There isn't one government which controls ESA, making the budget structure more elaborate. To make it fair, ESA divides its activities into two main categories: mandatory activities and optional activities. The mandatory ones are for the most part the most basic ones, like studies on future projects, technology research, information systems and training. When the mandatory budget is decided, all member states contribute to it proportionally to their gross national product. So in theory, everyone contributes the same relative to the size of their economy. But there are also a lot of ESA projects which might interest some countries more than others, and here is where the optional programs come into play. They actually are the majority of the operations and cover areas such as Earth observation, telecommunications, navigation, the ISS, microgravity research and space transportation. To encourage investment in optional activities, which often benefit everyone, ESA operates on the basis of so-called geographical return. This means that the agency's contracts are distributed more or less proportionally to each country's contribution to the given program. This comes with its pros and cons. On one hand, if a smaller country like Ireland decided to invest millions of euros into a project, they'd much prefer this money develop their own space industry, rather than, for example, that of Italy. On the other, it may lead to choosing suboptimal contractors for some specific tasks. This, however, does not happen that often, as ESA's requirements are clearly stated in advance, and a country is unlikely to choose an investment in ESA over other forms of help to the industry if their companies are not up to the task presented. As you probably know from the title, the agency's budget for 2022 is 7.15 billion euros, which is about $7.8 billion. This puts the European Space Agency only behind NASA and the Chinese CNSA, and does not include the money other huge European space agencies like CNES or DLR spend on their own operations. The number is big, however, gets much less significant when you remember that the member countries of ESA amount to over 550 million people. The agency compares the amount every citizen of ESA member states pays in taxes for the agency to be about the same as the price of one cinema ticket per year, 4 times less than in the US. This is also why the budget has been steadily growing for the past years, together with the European space ambitions. However, I firmly believe that this growth is still not enough in light of the upcoming race to make use of the high tech we can manufacture in space and green energy that can be harnessed. We definitely should be investing more. Moving on to who pays how much. Over a quarter of money comes directly from the budget of the European Union. Then the rest are the mandatory and optional activities, paid for by individual countries. As you can see on the graph, the main investors are France, Germany, Italy and the United Kingdom, which contribute the majority of the funds. Backtracking a bit to how the money is being spent, here is a breakdown of what portions of the budget are given to which activity type. It is indeed quite diversified and really helps understand the current priorities, allowing me to make a smooth transition to the question of who decides what those priorities are. The method of governance of the European Space Agency is to some extent similar to a public corporation. The equivalent of shareholders, so the member states, form the Council, which is the main governing body, deciding on the basic policy guidelines and the direction of the agency. You can see some photos from their meetings in the background. Each member state gets one vote on the Council, which meets at least twice a year at a delegate level and from time to time on a ministerial level, when the ministers in charge of space activities in the member countries meet. For the day-to-day operations, the Council elects a Director General, who together with his team of directors is responsible for bringing the Council's vision to life, leading the organization. The current Director General is this gentleman, Dr. Josef Aschbacher, who took office in 2021 after working at ESA for over 20 years. Since the European Union provides a significant chunk of the budget, every once in a while joint meetings of the ESA Council and the Council of the European Union are also organized, creatively referred to as the Space Council. When I read that, I could only think of that scene in Cyberpunk, though I would imagine that in real life the European Space Council would meet in a room with better lighting. On those, they can discuss the EU's flagship programs Copernicus and Galileo and any other future cooperation. And this cooperation is another interesting topic. The EU and its member states contribute over 86% of ESA's budget, effectively controlling it. But ESA is separate from the European Union, which seems pretty weird. Apparently, many EU officials at some point agreed that it is, and planned to incorporate the agency into the structures of the Union. This idea, however, was met with a lot of backlash from ESA itself and some industry partners. The leading arguments against this unification would be the issues with ESA member states and partners which are not part of the European Union, like the United Kingdom and Norway. Moreover, an argument could be made that it is good that ESA is a separate organization, as its policies can be disconnected from the regular politics of the European Union to the benefit of the scientific good. Personally, I don't fully support those arguments, as such incorporation would almost certainly not mean breaking any cooperation with other states to the detriment of all parties, and right now access to space is for the most part very much related to international politics. For now, however, there is no need to alter a system that works and is accepted by the space industry. ESA will remain independent, and quoting the EU Internal Market Commissioner, the European space policy will continue to rely on ESA and its unique technical, engineering and scientific expertise. This, however, does not mean giving up all power regarding the EU programs, which the EU showed in 2021 by reorganizing the European Global Navigation Satellite System Agency into the European Union Agency for the Space Program, which I mentioned at the beginning of the video. ESA did not like this move, but it is unquestionable that the programs envisioned and paid for by the European Union should be under its control. The idea is that ESA and EUSPA are to have distinct roles and competencies, in which ESA will focus on the technical elements of the EU space programs, and EUSPA will handle the operational elements of those programs. This relation is to be officialized in an agreement currently in the works, however its contents are still unknown at the time I am making this video. The creation of EUSPA also gives the Union very important capabilities, which I predict to be crucial in the future. ESA by its very nature is a non-militaristic organization, working exclusively for peaceful purposes, which is written into the convention establishing it. If in the future the EU needs militaristic space technologies, it would not be able to develop them with ESA, but EUSPA on the other hand could find its own contractors to manage such projects. The idea of a peaceful outer space is very noble, but in the current state of affairs many countries are not adhering to it, and Europe can't rely solely on the United States. It is my firm belief that we need our own response capabilities that hopefully would never need to be used. Which is also why it is good that both the European Space Agency and the European Union Agency for the Space Program exist. In this video we explored many different aspects of the European Space Agency, including its basics, operations, budget and relation with the EU. It is truly an amazing international project, bringing together most of Europe and ensuring its navigation and observation capabilities through programs like Galileo and Copernicus, access to space through Arianespace, and scientific edge with manifold valuable programs. I hope you feel much more informed about the agency, and who knows, maybe one day we will start to be proud of their operations enough to casually wear their logo on a t-shirt, just like the NASA logos. If you found the content informative and want to learn more about space, leave a like and a subscription. And maybe share the video with your friends, this really motivates me to work. I also have other great videos on the future space stations and some space history, definitely worth a watch. For now, I wish you nominal launches and a great day. Goodbye.